Hello, here we are with a 2015 Oxford Pat. It looks like we've got the same setup again. Maths first, physics second, no calculators. Yep, everything's the same, nothing's changed at all from previous years. Right, kicking off with the maths then. So expand this in powers of x. So let's do it bit by bit. So let's get our Pascal's triangle down. I'm going to do it rows just because it's easier to do all these bits in rows. So that's our 5 row of Pascal's triangle. So we're going to have 2 to the 2x to the 5, then 4, then 3, then 2, and then 1. I'll put it in 1 anyway. And then we've got this x squared, which is going to go the other way up. So actually, I'll just put them to the powers as we go along. So that's going to be 10, 8, 6, 4, and 2. So we just need to put all those together and then add them up. So 2 to the 5 is 32. So 32 x to the 5. Then we've got 16 times 5, so that's 80 x to the 6. Oh, x's are going up one at a time. 6, 7, 8, 9, and then 10 is on its own. Oh, we've got a 10 there. What are these ones in the middle then? So we've got an 80 there and a 40 there. So we just need to write those out in a row. I won't bother doing it. We can just say what they are. Just add them all up as we go along and write out those 6 terms. So a nice easy starter. But yeah, I find it easier putting them in rows. It makes it more systematic. I don't know, there's something about it. You don't have to do it that way, but you can end up being quite cluttered. If you put this first bit all in one row, then you end up usually having a sort of wrap text or something. So do it one term at a time and then write out the final answer. Just gives you a bit more space. Solve for x in this. So log to base 4 of 16, well that's 2. So we need log base 2 of x equals 0. So x is going to be equal to 1. Quickest 3 marks you're ever going to get your hands on. Always the way with the log ones. Evaluate this sum. What is the sum if the number of terms tends to infinity? Okay, so if we're doing sum to n, this is clearly a geometric series, so we're going up thirds at a time. So that is a 1 minus r to the n over 1 minus r. So that is going to be, first term is a third. 1 minus 1 over 3 to the 5 divided by, what would be 2/3. So that is going to be, what have we got? Well, a third divided by 2/3 is a half. And then we're going to have 1 minus, so what's 3 to the 5? That's going to be 81 is 3 to the 4, so it'll be 243. So that'll be 242 over 243, which is 121 over 243. What is the sum if the number of terms tends to infinity? Well, it'll go to a half. That's what goes on in it. This bracket, when you take this to sum to infinity, it's just that bracket disappears because mod r is less than 1, so it just becomes a at the top. So it'll be a half. Oh, they've really started off super easy so far. Right, this one looks a little bit more difficult maybe. So we've got to evaluate the integral of this. Okay, well hopefully that right hand bit, if the left hand bracket is the differential of the right hand bracket, then we're going to be all right. So that's going to be the integral from 4 to 6 of 2x minus 6. Then what's all this? We've got x squared minus 6x plus 8 to the half dx. So that's fine because if we differentiate the right hand bit, we get the left hand bit. So that makes things a lot easier. So we're going to have, what we're going to have on this, we'll have, whatever's in the bracket, which has then got to go up to the new power of 3 over 2 and then multiply by 2 over 3 to get rid of that. That's going between 4 and 6. So for 6, we've got 36 minus 36 plus 8. So we've got 2/3 of 8 to the 3 over 2. And then for 4, we've got 16 plus 8 minus 24. Oh, 0. So, right, that helps. So how are we going to do this? Square root of 8 is 2 root 2. Cube that, you're going to get 16 root 2. Double it, you'll get 32 root 2, and then divide by the 3. So actually that wasn't as bad as it looked. For what values of m does that have no real solutions? Right, so we're going to have to rearrange this into standard quadratic format. That's the only x squareds we got, isn't it? So then we're going to have plus 8 minus 4m, lots of x, and then we've got a minus 8 and a plus 3m. So we'll go with plus 3m minus 8 equals 0. So we need no real solutions. So we need our b squared, which is that, minus 4 times a times c, and we need that to be less than 0. So that is 64 plus 16m squared minus, what's that, 64m, and then we've got minus 48m, and 4 times 4 times 8, and the minuses are going to cancel, so 8 16s is 128. That's got to be less than 0. That's 16m squared minus 112m, you're going to have 16s about to cancel here, plus 192. It's got to be less than 0. So let's get rid of all these 16s, because that is 7, and that would be, what, 12? So that makes things easier. So we've got m minus 4, m minus 3, less than 0. So it's a positive quadratic where we want to be less than 0. So we're going to have to be between these. So m will have to be between 3 and 4. So a bit more work for the 4 marks. Very easy to do, but you have to work at it a little bit more. Right, the probability one. Unbiased coin is tossed 3 times. Each toss results in a head or a tail. What's the probability of 2 or more tails in succession? Right, so if we're doing that 3 times, we need 2 or more tails. So we can have tails, tails, heads, tails, 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 heads, tails, tails. And we've got 8 permutations all in all, because we've got 2 to the power of 3. So we're going to have 3 over 8 for that first bit. What's the probability that 2 consecutive coin toss results, coin toss results, if I can say it, are the same? So 2 consecutive results being the same, well, that's going to be a half. That seems ridiculously easy question to ask. Because, I mean, if it's unbiased, well, it's going to be a half if you're going to have 2 of the same in a row. Right, okay. Strange one to put in. That if any one of the toss results is known to be a tail, that all of the results are tails. So we've got 8 options. Well, there's only one option that doesn't have tails. So we can't have heads, heads, heads. So we're now out of 7. Because, we've got the other 7 of the 8 options. So if any one of the toss results is known to be a tail, right, so that's out of 7, all of them are tails, so that's 1 out of 7. Right, okay. So far, so speedy still. In the figure below, which is drawn only approximately to scale, the lengths of line segments AB, BC, CD, DA, and BD are all equal. All right, so I could have just said we had 2 equilateral triangles, but anyway. E is at the center of the larger circle. Cool. The smaller circle is tangent to all of those, has radius r. Okay, so we've got radius r. Derive an exact expression for the area of the shaded region. Okay, so shaded region is going to be, so how are we putting this together? We need the big circle minus the 2 triangles plus the little circle. So we know that the radius of the big circle then must be 3r. We've done this so many times. So that is going to be 9 pi r squared. We got a pi r squared at the end. So I'll come back to that bit at the end with a 3r thing, just in case you haven't watched the previous videos. So if we've now got the 2 of these triangles, so what's going on with each one of these triangles? We've got a 3r height, and that means that the half the base, because we've got 60 degrees in there, so we can look at the tan on this. So opposite over adjacent must be root 3. So it's going to have to be root 3r from D to E. So that's our half base times the height. So that's 3 root 3 r squared, and then we've got to double it, 6 root 3 r squared. Okay, so we've got r squared, what's that, 10 pi minus 6 root 3. I suppose you could take a 2 out as well. So let's go with that, 2r squared, 5 pi minus 3 root 3. That was really, really quick. Yeah, I mean, this thing, we've been through it quite a bit. You know, if you've got this circle inside the triangle, then we can split up into these triangles here. That must be 60 degrees. We know that that is r. So that gives us then that this bit here from the center up to one of the corners must be 2r, because that's just that 2r cos 60 is r. So that's how we work out that the height is then 3. It also gives us that this side here is root 3. So we didn't necessarily need to do the tan bit. We could have done a sine off of that triangle. So once again, the geometry question comes up trumps with giving us the quickest bunch of marks we could hope for. Question 8, find the slopes and y-intercepts of the straight lines that are tangent and normal to the circle of that at that point. Okay, so we need to get the gradient, so we need to differentiate this. So that is going to be 2 lots of x plus 3, then plus 2 lots of y minus 3 dy dx, because we've done implicit differentiation, equals 0. So that means that we've got dy dx is going to be equal to, well, we can cancel the 2's, so that's going to help. So, and well, let's deal with the minus signs. We'll have that, say that had a minus sign on it, but we can flip that round instead and make it a 3 minus y on the bottom if we're then dividing through and getting rid of the minus sign. So at 1, 2, dy dx, so our gradient is going to be equal to 4 over 1, which is 4. So that now means that we've got our tangent at that point is going to be y minus 2 equals 4x minus 1, and our normal is going to be y minus 2 equals minus 1 over 4 x minus 1. So we need the intercepts, don't we? So let's just rearrange this into y equals mx plus c. So that is 4x. We've got minus 4 plus 2, so minus 2. So we've got a gradient equals 4, intercept equals minus 2. That's done that one. And then we've got y equals, so that is going to be 2 1/4. So 9 over 4 minus x over 4. So gradient equals minus 1/4. Intercept equals, where are we, 9 over 4. So pretty straightforward. Providing you can do implicit differentiation, then this is really, really easy. You know, if you haven't done it, you just differentiate this as normal, as if there was an x there for the y, and then put a dy dx in. So yeah, you can go and check in a textbook or something like that. I'm not going to run through all of the background for that in here, because it will just drag on to making this video longer than it should be. By sketching the function below or otherwise, which pretty much means they want us to sketch it, find what values of y the function takes when x can have any real value. Actually, I'm not sure we do need to sketch this, because everything hinges on this first term. Okay, let's try it without sketching, actually. Normally, as soon as they suggest something, you want to go in and do it. But no, I'm going to say, right, so all hinges on first term. And that is going to range. So what are we going to say? X squared minus 4. So that ranges from -4 to infinity. That's the lowest value it can have is -4 because we've got positive here for x squared. So it goes from -4 to infinity. So let's split this up into chunks. So for -4 up to 0 for x squared over, x squared minus 4, then we can say that the first term, what will that vary over? So if we got -4 on the bottom, that's going to give us -2, which will then become 2. So the first term ranges from 2 to, if we got 0 at the bottom, then we've got infinity. But we're approaching it from the negative, so that will go up to, so that will be positive infinity. Okay, so that's fine. And so what about on the other side then? So for, what are we going to have? 0, I'll try it from 0 to 4. I was wondering whether to go all the way from 0 to infinity, but I'm not sure I want to, just in case there's something weird going on. So the first term here will range from, in this case, we're on +0, so that's sort of a -0, that's a +0. So this will now go from -infinity, because we're going to pick up that minus sign there. And when we've got 4 at the bottom, we're going to have -2. Okay, so that's good. And then let's do the last bit then. So we're going from 4 to infinity. So all of this first term bit, what are we going to get here? So we know we're starting at -2. When we go to infinity, we're going to get, well, we're going to get nothing going on here, aren't we? So that's going to go to 0. So that's our range on all of those. Now we need to shift all of those by 3. So shift, because we've got this -3 that we've got kicking here. Shift by -3. So we're going to be going from -1 to infinity, from -infinity to -5, and from -5 to -3. So the bit that we're not going to get is the anything between -3 and -5. So are we going to actually include any of those actual numbers then? So which ones are we going to touch on these? Because we're not going to get to the -3 when we go to infinity, because that's going to be below it. So we can't include the -3. And then what about for -1? When we're at -1, which came off of this point here, so that's when we've got -4, and that is exactly -1, so it will include it. So we're going to have that y is going to range from, well, it's got to be greater than or equal to -1, or it's got to be less than -3. Yeah, that was an interesting approach on that. I mean, we could have drawn it out. I mean, we've pretty much done, actually, I mean, we've done the work here of what it would be like to a large extent for drawing these things out, because you're seeing the values that we're going to be getting. We know we're getting asymptotes at these plus and -2s. So we're going to end up probably having something, I mean, maybe don't quote me on this, but having done all of this, we're going to get some kind of, something that's going to be looking a bit like this, I think. Yeah, it's going to look something like that, I think, this graph, because we've already picked out these asymptotes that are going on. That's going to be at -1, and we're going to have a horizontal asymptote here at -3, and you can't end up with the bits in between. Okay, this is just a sort of hunch sketch, so you might want to go through this sketch in detail to see that it is actually looking like that at the end. I mean, I think that's what we're getting presented with here, but we didn't necessarily need to look at it that way. I mean, going through the graph sketch of this, these are the things, you know, we have all these steps. What happens as x goes to infinity? Where are our asymptotes? this, that, and the other. How are we going to make these things happen when we've got x is huge and positive, x is huge and negative? What's happening with all of these things? And I think we're getting something along this idea. Yeah. So yeah, different approach maybe to question number 9. That's been the toughest one so far. For what values of x are the following inequalities satisfied? Right, this is looking disturbingly easy for 8 marks because they've not given us any squares or anything like that. So we can say then, I mean, a dividing point is when we're multiplying through by this x minus 6. So if x is greater than or equal to 6, then we've got x, well, it'd be 6 minus x has got to be less than 3x plus 4 and less than x minus 6. So what we're going to have on that, we've got that 2x has to be less than minus 10. Well, that's not going to happen for x is greater than 6. So we've got no solutions there. So that's good. So hopefully we'll have something for the other lot. So if x is less than 6, then we will have to flip all of the signs around. So we'll have 6 minus x greater than 3x plus 4 greater than x minus 6. So what is that giving us for all of this? We're going to have that 4x is less than 2, and we're going to have that 2x is greater than minus 10. So x needs to be greater than minus 5, x needs to be less than a half. Okay, there we go. So x is between minus 5 and a half. Yeah, that was really, really quick for 8 marks. Again, another reason for flicking through all the questions before you start jumping into them. And that is the end of section A. So with the possible exception of question 9, which wasn't actually that bad, but it was definitely the hardest one, that was a pretty quick section for as math sections go. So an easy start to 2015.